Okay, thank you so much for having me. This is great. I really appreciate the invite and so glad to give this keynote. Uh, so I'm Joe Spizak. I'm at Facebook AI. I'm a product leader on the platform team. And I'm here to talk to you about artificial intelligence at scale. I want to just start this out by talking about some of the trends I see, because I think this is really interesting. I think we love to talk about big models. We love to talk about the impact of machine learning and everything going on, but there's actually some trends that maybe not everyone is fully aware of, and I think these are really big drivers of how we actually see some of this research go forward and some of the production breakthroughs that we see. And I think number one, actually, that really people don't realize is that it's all about usability. And I think that's really what we have in this renaissance of language development, programming languages, Python ecosystem. There's a number of frameworks. There's of course things like Julia, et cetera. But if you look even in mid 2017, where Andrej Karpathy had this kind of, I don't want to call it a seminal tweet, but it got the community excited, right? He started using Pytorch, he moved over from a previous framework, and just tongue in cheek, basically said, hey, after using Pytorch for a few months, like things are never better. And what we found out during, over like the last few years is really usability is king. And this has been a really important driver overall for what's happened. So we've kind of gone from it being C, C++, like write your CUDA to support GPUs, to having things like cuDNN as a library, or having a nice Python, dynamic environment to develop in, and a bunch of libraries that give me, very ease of use in just about any domain you could possibly think of. And then there's a number of other projects that have really kind of taken things forward. Projects like Julia, which basically gives you this Python alternative and gives you basically differentiable programming and a really nice ecosystem around it. And then our friends at Google, who developed a project called JAX, which is, you could call it NumPy on steroids, but a very simple kind of functional way to transform and basically write really clean and compact code, because you just kind of wrap functions around functions around functions, and I can do, for example, gradients of gradients and gradients, and it's really easy to do. So kudos to that team. And overall, this is great. This is actually lowering the barrier to research, it's lowering the barrier to every developer who may push that next breakthrough. And what that has happened, though, is because this has happened, because we've been able to kind of push research forward, these new techniques, it's become easier. Production usage has exploded. So if you just look at Facebook alone, in the last 18 months, we've 2x the number of employees training models. We've lowered the barrier. So double the number of employees are training models, 5x the number of models trained. So that developer efficiency is starting to show through here. And you can argue this is a good stat or a bad stat, but we're using 8x in the number of computational resources, and that obviously points to the fact that models are getting more complex. We're getting into training more and more heavyweight models, things like transformers, which are computationally expensive, and we need to figure out basically how to do that more efficiently. And so I guess further to that, though, to help address this computational load, accelerators have, we've been talking about them for quite some time with cloud TPUs, even 5-6 years ago. And there's been a number of startups that have come out. There's of course NVIDIA GPUs, which keep getting better and better every year. There's FPGAs, and these are for both training and inference. And then of course there's edge accelerators. So in your mobile phone, or in your Macs, or kind of edge devices, and these basically are for both training and inference. And you can imagine training, doing things like federated learning for privacy and be able to learn on device, or efficient inference and low power inference. If you use an Oculus Quest as an example, there's a lot of computer vision, a lot of things actually happening on device, which is great because it doesn't require a round trip to the cloud, reduces latency, overall provides a really amazing user experience, and also improves privacy, right? You're not sending any data anywhere, the model's there. So from an overall user perspective, this is great, better experience, better privacy, and I can actually just run everything locally. The next trend I've seen is model diversity, and if you just think about the number of operators. So for those who don't kind of understand, like models are basically composed of operators. So things like convolutions or nonlinear functions like rectified linear units, and so on. And I think I looked at the PyTorch even a year or so ago. We maybe had like 400 ops. Now we're in kind of 1,000 plus range. A lot of this is really driven by research and what's happened. And these new types of operators, new types of models that are getting produced by research, and then we're finding product value, and so we want to make them optimal from a performance, from a memory footprint perspective, for training, different devices that are supported. So things have basically exploded. And really interestingly is the fact that 95% of them are non-convolutions. So and I'll talk more about that later on, but there's definitely things happening here, across a broad different types of domains, which is really interesting. And I think this, when I look at number 5 here, and this is this model size, I think this is what everyone loves to point to these days as the breakthrough in the space. And of course, absolutely. If you look at, just a few years ago with maybe like the BERT large model from Google, 340 million parameters. Before that, we were kind of in this 100 million parameter range. So these were relatively big models. Kind of BERT large took a step forward. And if you really fast forward just even a few years, things have exploded. Now we're in this GPT-3 range where 175 billion, we thought that was crazy. Then things are now 600 billion plus, and now we're in the trillion parameter range. And this is interesting because it really taxes our compute resources. And it's, but at the same time has been able to push the state of the art on a number of tasks. So basically at this point, we're trading a lot of like model complexity and parameters, for some gains in certain areas, and which is really interesting. This is a lot of this has been led by language models, but we're starting, as I'll talk about in a bit here, we're starting to see that push into other domains. I think because of this explosion, this has really forced us to rethink, I think, a lot of the tools that we're using as well. I think to be able to scale into the trillion parameters and multi-trillion type parameters, we have actually had to think about things like model parallel and pipeline parallelism and more efficient optimizers, being able to kind of shard things across devices, across servers, and do that in a way that is usable by these researchers. So this is actually a really big trend and something that actually does impact how we think about the tools themselves. The next trend I see, which is a little bit near and dear to my heart, which is the open source and startup combination. We are seeing a really interesting kind of renaissance of building community around open source, but also actually building a business model around it. So whether it's the folks at OctoML, with Tianchi Chen, who developed TVM, which is now Apache TVM, they're building a kind of a service around that for model optimization, or Gina, which is really neural search based on transformers and building a business out of that. To companies like Anyscale, and Anyscale is a company that came out of UC Berkeley, formed out of Ray, and this is like a collection of libraries that basically allow you to build the infinite notebook. They call it infinite MacBook Pro, right? I can train and use these type of tools in an abstracted way, but really underneath it's efficient hyperparameter tuning, distributed training, inference, et cetera. And this kind of suite of tools allows you to basically do essentially a serverless type environment where I actually don't care where any of my compute is running. It can be on a cloud, it can be on a bespoke cluster, et cetera. But from a user perspective, I can actually be writing Python essentially. So other trends I see, which shouldn't be understated. These are powerful trends, on their own. But responsible AI is something that is incredibly important to me. Something I've been working on, especially with privacy, for a number of years now. But of course, things like fairness and bias and transparency and interpretability, self-supervision, which we kind of used to be calling like unsupervised learning, is starting to become interesting and actually usable. And we actually released out of FAIR a library called Vissel, which provides a ton of pre-trained models. And it, self-supervised learning is actually quite computationally expensive. So having pre-trained models is incredibly valuable. ML ops, I think, this ML operations, this concept of basically operationalizing machine learning, having things like CI/CD in place or data validation. This is actually, it's an incredibly fragmented space, but everyone is really kind of coming together, and there's a number of communities around this that are trying to solve this problem. The tools are all over the place, but we're starting to see the world really pay attention here, and I have high hopes for this space because it really when ML ops becomes basically something we don't even need to think about, that's when basically machine learning can really get deployed at scale and bring large scale product impact, and not just impact at large companies like say Facebook or others. Really the world can start to realize the product impact of all everything that's happening here. And really this is about lowering that barrier. This is about putting the tools in place, things like pipeline DSL, or again data validation tools, or efficient inference and deployment, hyperparameter tuning, all of this basically end to end, such that users can deploy and manage their models in a production environment. And then lastly, of course, transformers continue to eat the world. I don't think there's any controversy there, but now we're seeing it with computer vision, which is really interesting because now we can actually see computer vision and language models and other models maybe start to come together. And multimodality type models are really important, I would say, because the world isn't a single modality. It's not just vision. We look at text as well. We might look at audio and speech. And we start to bring these different modalities together. You can actually improve the performance of your models, or you might be able to operate, for example, in different types of environments. And so this is incredible. I think we're all kind of converging on this around transformers, and we've definitely seen breakthroughs. And now, of course, computer vision is next. And the convolutions days actually might be numbered. We don't know yet. That's what some people are saying. Okay, switching gears, I want to talk about Pytorch and how we've thought about building an ecosystem at scale. So this is a really tricky thing to do because communities just don't, they're just not kind of born out of putting code out there on GitHub and poof, wow, a community just formed and started to contribute and build your project. I think this is something that takes, it takes a vision, it takes thought, it takes a community. And I want to just give you some insight on how we've thought about Pytorch and how we've been able to basically take the project from a small team of researchers that were actually cross-company and cross even university, where we had early contributors, really to what it is today, which is this massive multi-company, large-scale foundation of research type of project. And I'll talk more about that later on as well. So, when we fundamentally looked at Pytorch, we had to look at, things like cutting edge research, being production grade, being interoperable, and all of that wrapped around a community co-development. Pytorch was founded again on this idea of being flexible and basically supporting this fast ideation and research breakthroughs. That was the premise of Pytorch. Like, we want you to express any idea, go crazy, push the next breakthrough. At that time, really production wasn't even in sight. Then you bring in, when we started to unify the platform around Pytorch and Cafe 2, we needed to start thinking about production grade. So, things like performance, efficiency, reliability, scalability. We really didn't think about those in the early days of Pytorch because it was all about maybe training speed, because I want to be able to iterate quickly, train fast, and be able to kind of ideate quickly. Now I need to worry about deployment. I need to be able to do it reliably. I need to be able to be able to scale and be a large model in inference. And there's a constant tension between these things. So you can be like this Pythonic, I can express any idea in Python, but then I also need to be stable and rigid enough such I can maybe deploy to some type of accelerator in production, and be stable enough to be running maybe like personalization models or computer vision in an actual product. So when you think about this, there's this tension, and then you have maybe Facebook needs and you have the community's needs, and And really what we did there is really to strike the balance and have a wide set of workloads between the what we saw externally to Facebook as well as what the community needs. And so it's a really hard balance to strike, but we've actually been doing a really good job of that. And we did it in a very purposeful manner. I think the other piece of this is this interoperable ecosystem. One of the things that we see Pytorch as is this common language. So what is this, commonality, this way that we can kind of communicate and work with this ecosystem of projects around it? And that's really important because it's, something. It's kind of like seeing the future. It has this world of innovation that's happening outside of Facebook. People are doing things in computer vision or graph learning or privacy or an NLP. And so on, and we want to be able to interoperate with them seamlessly because fundamentally, like we ourselves can't enable everything. We don't know everything, and there are domain experts out there that are just flat out doing amazing stuff. And so, basically, creating this flywheel, this interoperable ecosystem, to cutting edge research over to production grade, and getting that flywheel spinning has started to create libraries, and you can see some of the ones that it's created, things like Fast AI with Jeremy Howard and Rachel Thomas, or Hugging Face, or down to OpenMind with some of the privacy libraries that they've built and started to actually scale at this point. And it's also actually allowed us to interoperate with some of the amazing libraries out there in the Python ecosystem. So Pytorch itself is heavily focused on being part of that Python ecosystem. So things like Rapids from NVIDIA for data science, or Ray out of UC Berkeley, or Apache Arrow, and so on. Switching gears, I want to talk about Pytorch a little bit and where it is today as an ecosystem really at scale. So, today the project is about 1,700 or more contributors. That's about 50% year over year, so it's growing incredibly fast. We have discussion forums where there's technical discussions, there's new ideas being developed. We have over 37,000 users on those discussion forums. That's well over, I think 10 or 15,000, year over year up, which is incredible. There's almost 60,000 projects on GitHub that are dependent using Pytorch. In research, we've seen, over 70% of the papers at NeurIPS, which is one of the top conferences in AI, citing Pytorch or using it with the code that's submitted. Archive itself, where basically these days everyone puts their papers. We see year-over-year growth that's incredible. You can go to paperswithcode.com/trends, and you can actually see all the papers with code and all the papers with code that have Pytorch that are built in Pytorch. In production, as I mentioned, there's a lot happening. Some of our partners that we do co-engineering with are companies like Disney or AstraZeneca or Uber or Tesla, Microsoft, and others. At Facebook, I mentioned it's a big part of how we develop and deploy machine learning today across all kinds of use cases, from computer vision, NLP, personalization, on device, et cetera. And if you look at the community itself, it's actually made up of a lot of different users and a lot of different contributors. So whether it's full-time folks like NVIDIA has a team, or Amazon and Google have teams, or Microsoft, these are full-time developers in Pytorch. That's their job to contribute to it. It's pretty amazing. But then there's also the other 40%, which is folks that maybe aren't at big companies, or maybe they're even in universities, like Vishwak over at CMU or Simon over at MIT, who work on this when they can. They've been contributors over the years, and it's really maintained its community feel. These are folks that we do talk to on a regular basis through GitHub or on Slack, and they are a core part of this project. And what's interesting is, of the people who have only contributed once this year, there's actually 13% of those. So we actually have this long tail of people who pick up issues, pick up small features and contribute to the overall success of the project. And that's actually 13% of the contributions, which is just nuts. So it really does have a broad base of folks that are part of this community. And this really didn't happen overnight. I think one of the things that we've done is actually empowered community members. We've done things like Help Wanted. We're contributors provide RFCs. We have discussions, et cetera. It really is a welcoming and warm community that anyone feels like they have a voice and can contribute. And lastly, one thing I'll mention is just the Pytorch ecosystem itself. This is a sampling of projects. If you go to pytorch.org, you can see there's really a project for just about anything you want to do, whether it's I don't know, quantum computing, to NLP, to hyperparameter tuning, to computer vision. There's basically anything out there. And actually, I would say most of these are not from Facebook, but they are used across the community. And we've started to use a lot of these internally at Facebook. So it's a really great partnership with a broad community. And lastly, just check out pytorch.org. Come to the forums, say hi. If you have an issue, post an issue. But you can also learn at pytorch.org. There's tutorials. We have links to Colab notebooks directly, so you can get started basically right away. And just want to say thank you again for inviting me. I really appreciate the invite, and hopefully you check out Pytorch. Thank you again. Cheers.
I guess the first question that we've got for you is that throughout your career, you've been looking at AI and open source AI. Do you see that being an ongoing trend, that open source is the way forward? And do you see it where it might ever stop?
I don't, honestly. I think we're at a point now where open source is here to stay. I think that era of proprietary and kind of black box platforms, I think is far gone. I think if you look at all the development that's out there, it's it is based on open source, and there's also a number of startups that are building businesses around open source. So whether it's Hugging Face or OctoML or Gina or Grid or Ray or Anyscale, all these companies foundationally have an open source project that is on GitHub. It has a community. It's not out there just for show. If you look at the platforms that cloud providers are providing these days, they realize that they can't provide a black box anymore. It's built on open source, PyTorch and TensorFlow and JAX and all these projects. That's the entry point for developers these days. They want to be working on things that are transparent and have communities around them.
So I work within BT, and I know BT has a lot of patents in artificial intelligence, but they range widely actually from network to security to other aspects. When do you think it's right for AI to be patented, or when to open source it?
This is a really tricky one. It obviously depends on the company and the motivations. I've seen some of the things. I know Google tried to patent batch norm and a few other things. I believe they actually got North America patent on that. And I think for example, Microsoft had some patents around some of their algorithms for how they scale a few years back, and they had more like restrictive licensing. I think the thing here is you have to weigh the pros and the cons and really the benefits and the trade-offs of doing that. Because I think generally speaking, I think the AI community is very open. It's very collaborative. When something comes and it's got a heavy patent element to it, people tend to shy away from it and try and move towards things that are more open and permissively licensed. So if you look at the projects out there these days that are, incredibly impactful. Just look at Apache Spark. Of course, it's Apache 2 license, which is incredibly permissive. A lot of the new projects are, it's kind of like table stakes these days for projects to be, like BSD3, Apache 2, MIT, basically licenses that allow commercial usage or some level of permissiveness.
So in terms of where we're trying to look at, and people in the audience are trying to look at machine learning and AI, and actually sort of do the fundamental research on some of these things and really expand out some of the ideas. Many people, I'm sure, will be wondering, how do you get from a point where you've got lots of ideas right the way through to, okay, well, now let's actually put them into operation. Let's productize those things. Let's productionize those.
If you look at like the transformer models, they're incredibly computationally intensive. Like, for example, BlenderBot, which was an NLP bot that you can play with on Messenger. I think you just do like hashtag BlenderBot. You can actually converse with it, and it's quite good actually. That was I believe close to a 10 billion parameter model, and actually to do inference on that model actually took 4 voltage GPUs just to do kind of inference at some reasonable level, which is pretty nuts. It's a lot of compute for inference. Yeah. And so there's a bunch of things that you do need to take into account. So once you've excuse me, once you've kind of trained a large model, it doesn't just magically, transition over into a production environment. You have to think about all aspects of things, right? You think about ML ops. Is it something that is going to continually train on new data? How does it actually work? How do I A/B test it? Where am I going to deploy it? Is it going to be on device if you're running on device for latency reasons or potentially privacy reasons? Taking a transformer as an example isn't going to be a tractable problem, at least yet. So you might have to do things like prune the model. You might have to do things like quantize it. Any type of model optimization to basically distill it down to something that can run in a compute constrained environment. From all of the things around production, you might have policies on how much data you can train on. So you might be able to train this really big proof of concept model on this large corpus of data, but in production it might be a little bit different. You might be more constrained, or and so on. So there's really everything from like the data validation piece to the continuous integration and continuous deployment pieces, all the way through to thinking about bias and thinking about fairness and privacy. I might need to retrain the model differentially private. I might need to use things like federated learning. And so you kind of all have to kind of consider those different aspects when you actually want to deploy it in a real production environment.
Perfect. Well, Joe, so I'm conscious of time. We've only got a couple of minutes. So there's one thing I was really keen for you to put to you was in the audience right now, we've got a whole bunch of students, whether they're college students, university students. What you've had, like I say, you've had a great experience in a number of different sort of posts in your career already. What would your advice to those guys be?
I mean, my biggest advice is really to get your hands dirty, be part of communities, grow your knowledge in the space. I think it's funny. I mentioned this earlier, but I interact with anyone from like people who lead large labs, like Fair and Facebook, all the way through to high school students and folks that are just aspiring to get into this space. And it's really fun for me personally, because I get to see the thought leadership and I get to see where the direction of all of this is heading. And then I also see kind of what the future looks like and the aspiring, folks that are looking to get involved and just be part of it. And I think one kind of anecdote is, one of the reasons like in Pytorch, we don't have a certification like maybe other frameworks or other projects do. In the community, it's really more about what you do with the framework and what you build. And so, my advice is just build something or get involved with communities that allow you to build something. And I think we've been lucky enough to have great partners like, for example, Jeremy Howard at Fast AI, who has an incredibly broad and global community of aspiring deep learners. These are folks that come from all walks of life. They pick up Fast AI. It's built on PyTorch. They have discussion forums. It's incredibly organic. They jump into little projects and they start to build their knowledge and learn how to code. And the other community is probably Open Mind, which is Andrew Trask's, which is he's based over in Oxford, and they have an incredibly organic community with this mission of building privacy into applications. I introduced him to a colleague's son who's in 10th grade, and now he's working on basically bringing privacy into NLP models with large scale transformers. And he's a sophomore in high school, and doing this work with Andrew and this team. So to me, it's like get involved with these communities. That's where the action is in AI. It's not like getting these rigid certifications and all that. I think we're kind of past that point. We're to the point where it really is very organic and community and really like word of mouth or who you engage with and how you interact and the stuff you do is actually the merits of what people see in your work. And that's kind of like the foundation of open source. Like you can be anyone, right? You can develop something amazing, and it can just shoot to the top of GitHub, and it really doesn't matter what walk of life you're coming from. So
unfortunately, we could talk all day. I could talk to you all day. But yeah, thank you ever so much. We've run out of time now, but again, really appreciate your time. Thank you so much, Joe. And
awesome.
yeah.